Welcome to our video series, MPLAB X IDE Advanced Debugging, Breakpoints. This video should serve as you hold your debug challenge in mind as a reminder of the different techniques to try and apply to your debug context. We use a very simple device, PIC16F, to show how we can apply many of these advanced techniques even if you have a simple 8-bit microcontroller. We start with some theory, how the breakpoints work behind the scenes, then build up context, the MCC Hello World project. In videos 3 and 4, we cover line and address breakpoints, which are both program breakpoints. Video 5 covers data breakpoints, and up until this point you can see that there's hardware tool debug support for this microcontroller. For sequence breakpoints and event breakpoints, we go into the simulator to show off these features. Let's dive right in. In main, the first thing we do is set a line breakpoint on LED toggle. We can open the breakpoints window. We can see breakpoint is set. Start a debug session. Our breakpoint is hit and count has a value of 1. If we edit this breakpoint, set a pass counter of 2, reset, run, our count value is 3, showing that this line was passed twice and on the third time it broke. Let's open Debug Disassembly. Run again, and you can see that we break and have synchronized our disassembly with the source code. Based on the kit window and the schematic for this kit, RA2 going low turns the LED on, clear if, so we set a breakpoint here. Note that this is an address breakpoint because it is at a machine or assembly level. Behind the scenes, all line breakpoints are address breakpoints. MPLAB X just manages which address each source code line breakpoint is associated with. So running, when we hit this breakpoint, step over, our LED turns on. Note, as we uncheck certain breakpoints, the debug resources available in the project dashboard updates. Next, we'd like to look at data breakpoints. Here we can see count is a global variable, has a value of 2 and is located at address 6E, and you can see that that comes up if we add count in that way. Alternatively, data breakpoint symbols, global symbols. Here we can see count and it's added as a breakpoint. We can break on writing a specific value. Let's set 5. Okay. Reset. Run. When we break, count has a value of 5. Note that if we move count as a local variable, hit debug again to recompile, now count is at address 6A, and you can see we still break now on that variable. Up until now we've just been monitoring the LED. Let's have a look at how the UART is performing. The MPLAB data visualizer will be useful for this. So connecting to data on COM4, we can see once we've programmed what's happening on the UART. Now if we'd like to break on the exclamation point, we can see that the URI function, which is in turn used by printf, can set another data breakpoint. After checking on our ASCII table, we can see that an exclamation point is 21. Start a debug session. And you can see we break with the exclamation point, and at that point we stop just before the D, so there's a couple of characters buffered. Resetting and running again, you can see that we stop at this exclamation point here. If we'd like to skip this one and break here, we would need to set a sequence breakpoint. That is not supported in hardware, but is supported in the simulator. So we need to change our project configuration. If a debug session is opened, you'll need to unlock this. Select the simulator. So we need to apply first. We can't use the data visualizer with the simulator, but we can use a UART.io as an output. Now we can set a line breakpoint on the line of interest. We have a data breakpoint already, so we can add to a sequence. Restarting the debug session. You can see we've paused at the exclamation point. And checking the output from the simulator window, we can see we have broken where we expected to. The last breakpoint to demonstrate is the event breakpoint, which is supported just in the simulator. Going to device config, our watchdog timer is off. I can set this to on and set a event breakpoint when watchdog timer has expired. Sequence breakpoint, delete it, reset, run. User program is now stopped. Looking at the simulator, you can see that a breakpoint event, watchdog timer expired, and the simulator halted, and so that is working as expected. And you can see how much of the program runs before we hit the watchdog timeout. For a more detailed handling of each of these breakpoints and features, please watch the rest of the series. Thank you.